Hello students, in this video
we'll see the properties of determinants. First property is determinant of a matrix remains unaltered if its rows are changed into columns and columns into rows. That is, if I take matrix A 1, 2, 3, 4, 6, 2 and 3, 4, 2. 3, 4, 2. This is the matrix A. Now, the determinant value of this, you learned yesterday how to find. 1 into 6 into 2. Cross this row, cross this column, 12 minus 8. 8. Then this place, odd, it's odd place, put minus. Minus 2 into, cut this row, cut this column. 8 minus 6. Plus 3 into, cut this row, cut this column, 16 minus 18. So that is equal to 12 minus 8 is 4, minus 2 into 8 minus 6 is 2, plus 3 into 16 minus 8 is minus 2. So it is 4 minus 4 minus 6, we got it as minus 6. Now first property says, that is property 1 is, if you take the transpose, A transpose, that is you interchange rows and columns. So first row will become 1, 4, 3, 2, 6, 4 and 3, 2, 2. We took the transpose now. So the property says the value will not change. You can just check. See, 1 into 12 minus 8. Then minus 4 into, cut this row, cut this column, 4 minus 12 plus 3 into 4 minus 18. So that is 12 minus 8 is 4. 4 minus 12 minus 8 into minus 4 plus 32. 4 minus 18 is minus 14 into 3 minus 42. So 36 minus 42 is minus 6. So the value is not changed. So determinant of A and determinant of A transpose both are equal. That is first property. Now second property is, if any two rows or columns, whatever we are saying for row is applicable for columns also, of a determinant are interchanged, the determinant changes its sign but its absolute value remains unaltered. That is, if you interchange any two rows or columns, that means R1 and R2 I am going to interchange. R1 interchange, this is a sign we use for interchanging. So I am going to interchange R1 and R2. So what happens here? First row will become 4, 6, 2. Second row will become 1, 2, 3. 4 into 4 minus 12 minus 6 into, I am expanding using first row, 2 minus 9 plus 2 into, cut this row, cut this column, 4 minus 6. So what do you get now? 4. 4 minus 12 minus 8 minus 6 into 2 minus 9 minus 7 plus 2 into 4 minus 6 minus 2. So that is minus 32. 6 into 7, 42, then minus 4. So minus 36 plus 42. What is the answer? 6. But determinant of A, answer is, what is the value of determinant of A? Minus 6. When you interchange two rows, what happens? The absolute value remains the same. The value has not changed. The sign has changed. So if you interchange two rows or columns, what happens? The sign of the determinant will change. So that is a second property. If two rows or columns of determinant are interchanged, the determinant changes its sign, but its absolute value remains unaltered. Property 3. If there are n interchanges, suppose if you interchange twice, the determinant will not change the sign. So if you interchange 3 times, minus 1 power 3, the sign will change. If you interchange 4 times, the sign will not change. There are n interchanges of rows and columns. The determinant of the following matrix is minus 1 power n. If you interchange twice, the value will not change. If you interchange 3 times, the value will change. The sign will change. If you interchange 4 times, the value will not change. So if I interchange n, property 3, if I interchange n times, that is if I interchange 1 time, the determinant value will change the sign. If I interchange 2 times, it will not change. Suppose if I interchange R1 and R2, then R2 and R3. So twice I am interchanging. If I interchange twice, the determinant value will not change. If I interchange 3 times, again the value will change. The sign will change. So when you interchange even number of times, the value will not change. It is the same value you will get. But if you interchange odd number of times, negative of the determinant A. Property 4 is if 2 rows or columns of a matrix are identical. Identical means suppose if I have 1, 1, 2, second row also I have 1, 1, 2, third row suppose 3 something else. If 2 rows are identical, if you expand it, you will get the value as 0. R1 is identical. This is a sign for identical. If 2 rows are identical, you can expand and check. The determinant value will be 0. So whatever we are proving for row is true for columns also. Property 5. If a row of a matrix, that's what is given in the bracket, column. So whatever we are saying for row is true for column also. If a row of a matrix A is a scalar multiple of another row, then its determinant is 0. That means property 5. Suppose one row is 1, 1, 2. The second row is, you multiply the first row by 3. What do you get? 3 is a scalar multiple of the first row. So what is R2? The scalar multiple of R1. Okay. So I am going to multiply by 3 some number. Then third row as it is. So here what happens? The second row is a scalar multiple of, second row is actually 3 times row 1, correct? So in that case also determinant value is 0. How? The second row you have a common number 3, take it out. So if in any one row, if something is common, you can take it out. Not like matrices. Matrices, you can take the constant out only if you have a common element everywhere. But in determinant, if any row, just take this row, you have 3. One row or one column, it is enough. So I have taken 3 from the second row. So you get 1, 1, 2. Then this is 3, 4, 5. Now I use the property 4. The property 4 says 2 rows are identical, the value is 0. So if 2 rows are proportional also, the determinant value is 0. Scalar multiple, then its determinant is 0. Next is if all the entries of a row or a column, all the elements are 0 means what happens? It will be 0 only. If all the elements are 0, the determinant is 0. The determinant of a triangular matrix is obtained by the product of principal diagonal. That is triangular matrix. What is a triangular matrix? You will have 0, 0. This is one triangular matrix. You can have any number here. This is a triangular matrix. Now this is a upper triangular matrix. So what is how do you find the determinant value? You just multiply the elements of the this is the leading diagonal. This is called as the leading diagonal or the principal diagonal. Just multiply the elements of the principal diagonal. That is enough. You need not expand. So just multiply 3 into 1 into 1. 3 is the determinant value. So if it is a triangular matrix, you need not expand or anything. Just multiply these elements. Now property 6. If each element of a row is multiplied by a scalar k, the determinant is multiplied by the scalar k. Suppose if you take a determinant, this one you take. So this is the value is minus 6. Now if I multiply a row by 2, any scalar, I am going to multiply the first row by 2. So what happens? It will become 2, 4, 4. 4, second row I am not doing anything, only one row I multiplied by 2, only one row. So what happens to the determinant value? The determinant value will now become minus 12. Why it will become minus 12? If I multiply a row by 2, okay, and this is 3 I think. I am going to multiply row 1 by 2. So the determinant value will also be multiplied by 2. If it is minus 6, it will become minus 12. If I multiply the row, any row, if I multiply row 3, if I multiply row 3 by 4, what happens to the determinant value? It will be multiplied by 4. Determinant value will be multiplied by 4. That is, the determinant value will be minus 24. If I multiply any row by a scalar, the determinant will change. So if I multiply any row by a scalar k, then the determinant value will also be multiplied by the scalar. If I multiply by k, it will be k into minus 6. If I multiply by 2, it will be minus 6 into 2. If I multiply by 3, it will be minus 6 into 3. So that is the property. Any row or a column is multiplied by a scalar k, the determinant is multiplied by the same scalar k. If this is delta, if you multiply, see here they have multiplied the first row by k. So what happens to the determinant value? It will be k times delta. Delta can be anything. If it is 3, it will be k times 3. Property 7 is, if each element of a row or a column is expressed as sum of 2 or more terms, then the determinant is expressed as sum of 2 or more determinants. Here you can see the first column is expressed as sum of 2 terms. Can you see that? The first column is expressed as sum of 2 terms. That is, you have a1 plus m1, a2 plus m2. 2 terms are there. So what happens now? The determinant is also split into 2 determinants. The second column and third column as it is. We are not changing anything. You can see that. The first element, first column will be the first element here. A1, A2, A3. First elements A1, A2, A3. The second determinant, the first column will be M1, M2, M3. Understood? So if any row or any column is expressed as sum of 2 or 3 terms or more terms, the determinant will also be expressed as sum of 2 or 3 determinants. So property 7 is, you can split the determinant into 2 determinants. Properties 8 is, if to each element of any row you take, for example you take R1, what are you going to do? To each element of any row of a determinant, equimultiples of the corresponding entries of one or more rows are added or subtracted, the value of the determinant remains unchanged. So that means with row 1, I am going to multiply a constant here. It can be anything, k times R2 plus P times R2, Q times R3. The value will not change. To any row, I am taking row 1, you can add with that row 1, you can multiply row 2 with some constant, some scalar. For example, you can multiply P. See, with the row 1, you are keeping as it is. With the row 1, I am going to multiply this row 2 by some scalar P and this row 3 by a scalar Q, and all these I am going to add with row 1. See, row 2 multiplied by a scalar P and row 3 you multiplied by a scalar Q. Then everything we are adding with row 1. The property says the determinant value will not change. Not only add, you can also subtract. You can write R1 is R1 minus some times R2. So we can do that. The property, that is, the value of the determinant will not change. This is a very important property. We'll be using this very often. So these are the properties that you're going to use to do that exercise 7.2. So let us see the first sum. Without expanding the determinant, prove that, this is exercise 7.2. Prove that s a square b square plus c square, s b square c square plus a square, s c square a square plus b square is 0. What is the right hand side here? It is equal to 0. That means two rows you can make identical. Okay, you can make two rows identical. So first thing is two rows or two columns. So already you have an S here. Can you see that? S, S, S. So we can take that, you learned that property. If you have anything common in any row or column, we can always take it out. So it will become first column. From first column, S is common. Take it out. Second column, a square, we are not doing anything, b square, c square. Third column, b square plus c square plus a square and a square plus b square. Now, how can you make them identical? S into 1, 1, 1. Now, if I add column 2 and column 3, we can add, isn't the property, last property is that to any column, any row, you can add the other rows or other columns. So I am going to add these two columns. So what happens when I add? Just add and tell me a square plus b square plus c square. Column 2 and column 3 I am adding and I am putting it in column 2. B square plus c square plus a square. C square plus a square plus b square. So column 2 I have changed. The third column as it is, a square plus b square. Now you can see that in the column 2, a square plus b square c square is common. Take it out. So you will get 1, 1, 1. Here also you will get 1, 1, 1. B square plus c square plus a square plus b square. Now this is equal to 0 because column 1 and column 2 are equal. We learned the property, if two columns are identical, the determinant value is 0. Two rows are same. So this is 0. S into a square plus b square plus c square. This is 0. So it is equal to 0. So we have proved that the determinant value is 0. Yeah. Second question again, we have to prove that is equal to 0. So whenever you have this BC, CA, AB, BC, CB squares, that is here A is missing, here B is missing, here C is missing. If you see problems like that, you multiply that first row by A, second row by B, third row by C. If you multiply, you know the value will change. You learn the property. If you multiply determinant by a constant K, the determinant will change its value. So when you multiply, you should also divide. So I am going to multiply R1 by A, R2 by B, and R3 I am going to multiply by C. So when you multiply, you should also divide. So I will write the division A, B, C, multiply, divide by A, divide by B, divide by C. So what I am going to do here, multiplying row 1. I cannot multiply one element by A. I have to multiply all the elements by A. So it will become A into B plus C, A, B, C, B square, A, B square, C square. Second row I am going to multiply by B. So what happens now? B into C plus A, B, C, B into C square, A square. Third row I am going to multiply by C. So C into A plus B, yes, is A, B, C, C, A square, B square. Now what is common here? Second column you have A, B, C common. Take it out. So it's become A, B, C. Already one A, B, C is there. Now you have this, you can cancel A, B plus AC. Here 1. Here AB, B square, C square. This is BC plus AB. This is 1. This is B, C square, A square. CA plus ABC, 1. And here CA square, B square. Now, you can see in the third column, everywhere you have ABC, isn't it? ABC, BC, ABC here. ABC, it means ABC is common again. So, take out that ABC. From third column, take out ABC. So, the first column as it is, AB plus AC. Second column, BC plus AB. CA plus BC. This is 1, 1, 1. I have taken ABs. That means what is left here? BC is left. And here, what is left when I take CA? Here, ABC I have taken. So, AB is left. Now, you want to prove it equal to 0. So, try to make two identical rows. Already 1, 1, 1 is there. Now, if you add, just see, AB plus AC plus BC. Whatever is missing, it is here. BC plus AB plus AC. So, if I add column 1 and column 3 with the column 1, I am going to add column 3. So, if I add, this will become ABC. So, first column will become now AB plus AC plus BC. I am adding these two. BC plus AB plus AC. AC plus BC plus AB. Then 1, 1, 1. This as it is. AC, AB. Can you see AB, BC, AC here? AB, BC, AC. AB, BC, AC. The same term. We can take it common. AB, BC plus CA common. I can take it out. So I will get 1, 1, 1 here. 1, 1, 1. BC, AC, AB. What is the value of this determinant? 0. This is 0. Because reason you should write. Column 1 is equal to column 2. So determinant value is 0. So this is equal to 0. So we have proved LHS is equal to RHS.